So at Maveneer, anything is possible is a mantra that applies both to our team and to our clients. But it really starts with our team. For our team, it means that one day you might be designing a bespoke mechanical product. Maybe you're using FEA tools or iterative design tools to accomplish that. The next day, you might be working with big data. You might be using machine learning. You might be deploying nonlinear optimization algorithms, all so we can provide the best solution to our client. So, like in essence, it means that we use our broad skill set to solve problems in the best way possible. And this flows downstream to our clients, where that broad skill set and that problem solving approach results in unique solutions that they're not going to find elsewhere in the market. An example of this flowing downstream to our clients is a particular client where we were space constrained in designing a conveyance and sortation system. In being space constrained, it made it difficult, downright impossible, to use off-the-shelf equipment to label packages fast enough. In this particular case, we went back to our first principles approach, applying basic physics and math to understand what is the root of the problem. How can we apply labels faster than these products or these off-the-shelf solutions? In the end, we were able to take those off-the-shelf products and control them in a different way. Capability existed in the hardware. It was all a matter of control. And we were able to control them in a way such that we were able to speed up labeling and squeeze a high-speed labeling system into a space that would otherwise not accommodate. This allowed us to install a conveyance and sortation system in a facility which was very space constrained, in a live environment as a retrofit. And in the end, what was originally expected to be the bottleneck in the design, utilizing off-the-shelf equipment, is no longer a bottleneck. In fact, the bespoke solution that we were able to offer would allow the client to spike their output, to surge it to maybe even double the design rate of the entire system. And the labeling system would hold up. Typically, the aha moment in a project, or the, oh, I've stumbled upon something part, occurs in the early phases when we're dealing with large client data sets. We go and visit the client's site. We observe their processes. We then take data, large data sets from the client, and we start to put the pieces together. What is the volume that flows through a particular process? What is the productivity of that process? What is the situation for dependent or downstream, upstream or downstream processes? And it's when we start applying client data and when we start to slice it and look at it in different ways and utilize some of the tools that we have at our disposal and that we've created, that we get insights into where in the process we see bottlenecks. Not even a specific process per se, but a specific aspect of one specific process. And an example can be, what is the distance of a label printer from an operator standing at a workstation? If the label printer is 6 feet away instead of 2 feet away, then they have to take a few steps. Multiply that times every package that they're working on through the day, multiply that across dozens of operators, across 365 days a year, and it adds up to significant labor expense. Those are typically the aha moments. Yeah, so what we typically do is we start with the client's own data that they understand in the terms that they understand. And there's this gradient or transition that occurs as we move from the client's input data and the operational observations into modeling space and into simulation space. And then we start to turn the knobs in the modeling and simulation space. And as we walk through those steps with the client, they're able to see with the math and the science how their operation might be different in these alternative scenarios. And that allows us to recommend alternatives hand in hand with the client, even if they're radically different.